Okay, we've seen now how to set up the basic grain simulation. So we have our grain source here that also creates a p-scale and makes sure that the points have the right distance. And then in the popnet, we need a pop grains node that takes care of the simulation. And very important, make sure you have enough substeps. In this case, I set it to 20. More, of course, would be better. So, and if you run this, the points are actually colliding. And you can see once it's fully simulated that it behaves a lot more like sand now than before. So this is how it looks like in real time after I simulated a little bit, and you can see, you know, we have a nice behavior that looks really sandy. So we will talk about this more and all the settings we can do, so it's more clumping and all that kind of stuff. But let's talk about how this looks first, because all we see is points, and that's actually pretty hard to judge the whole thing. While the behavior kind of behaves like sand, it doesn't feel like sand, it feels like points, right? Now what you could do, of course, is you just take a sphere, and maybe if you're clever, you use a primitive sphere so that you don't have too much geometry that is needed to be calculated, because it only is made of one point. And then, of course, use a copy to points and copy that onto our points. Just make sure that, and you can see that here, those points here on the ground, that comes from our ground plane. So let's make sure that we only take our pop groups, our pop objects out of the simulation. And then it looks like this. And because the p-scale is correctly set and our sphere has a radius of 1, we now have spheres, and that's fine. The problem with that is if you have a lot of points, that becomes very slow. And later on in examples that are really kind of production ready, you will need a lot of points, because sand, you know, each grain is so small that we're talking about millions of points. In this case, we only have 40,000, which is way too low. This is really just for the tutorial. Now, what alternatives do we have? Now, there is a built-in system that is part of the pop setup that is called Pop Sprite. And the idea here is, instead of actually copying geometry on our sphere, you can see that when I click this in, we get some kind of, little blob here on where the points were before. And what this is a sprite. So this comes out of the old game engines, and it's basically a texture that always rotates towards the camera. And the idea here is that we don't use this little puff here that is already pre-built, but we can choose from the textures. If we go into one higher folder, if we know what we're looking for, we can find the sphere mat, and this is here, spheremat.pic. And nothing happens because we quickly have to make sure our frame is rebuilt. So let's just change the frame, and there we have it. Now it looks like spheres. Again, the idea here is that those are just textures, so they're much faster to calculate and to visualize. And it's a nice little trick to give the impression of having spheres without actually having spheres. But as we will see in a second, it has a lot of disadvantages. But before I do this, let's talk about another thing that comes with it. And that is, you usually use a pop color with this. So the shape that we visualize our points with and the color can be changed with the pop sprite and the pop color. And the pop color works in a way that we can use a ramp here. And by default, it uses the age attribute, but instead we want to use a random part of this ramp here based on the current point number. And you might think you should use ID here, but actually it's ptnum, because the point number is not changing in a grain simulation usually. Of course, if you for some reason emit those points, then you would use ID. And here now, if you choose something that looks a bit more like sand, maybe something like this, you can see you can colorize your points. And actually, I think there's even a preset here called sand. So let's use that one. So that is usually the way you do it, at least if side effects has anything to say. But there are a couple of problems with this approach. First of all, when you change any of the two nodes, let's say we just change this small slider here, then you can see that our simulation is broken, because this is now part of our simulation setup. And as soon as we change anything, we have to resim the whole thing, even though we just changed the color. Not great. The another thing that is not great about it is you might have noticed we actually don't have any light reaction. So let me quickly prove this to you. If I create a new light, a point light, and just move it around, you can see there nothing happens here, which is really annoying. Now, to be fair, keep one thing in mind, which is very important. If I render the whole thing, then those pop sprites will be ignored anyway. Not the color, but the pop sprites. because at render time, because we're dealing with points, they will be replaced with spheres anyway, and then you have a proper light reaction. So ultimately it's not a big deal, but for the viewport at least, it's kind of annoying and not really helpful to not have any kind of light reaction, which of course comes from the fact that we're looking at textures here. So what's the better alternative to this workflow? By using the internal viewport function to actually represent those points as spheres. You can turn this on actually by default for all points when you go into the display settings, and then under geometry you can see here display particles as points, and you could, if you want, to change this to lit spheres. And there you see where the advantage of this is. They are actually reacting to light, but are still pretty fast, much faster than if you have to actually copy geometry onto the points. So this is a big advantage. But the thing is, you don't always want to do this for everything in your view, but only for your grain simulation. So let's turn this back off and do the same thing just for these points, because you can do this on a per geometry basis with the Visualize Properties node. And here you can do the same thing just for the points that are connected via points as spheres, and then you enable that and you have the same thing. And a little side note on this for all the nerdy folks, if you want to, you can actually have the same result by simply setting an internal kind of magic attribute, and that is called GL sphere points. And when you set this to 1, tada, as you can see, you tell the display to do the same thing. So of course this is an integer. When you look at what comes out of the Visualize Properties node, you can see here, this is what it sets on the detail level, GL sphere points, but you can set this on a per point level as well, or if you want, of course, on the detail as well. That's one thing. The second thing is colors, and for this I would use the attribute adjust color that we saw before, because it allows us to set the colors to random, but by default it already will do this via a ramp, and then we can choose the ascent again, for example, and there you have it. If I increase my lighting a little bit, there you go, we have a nicely lit version of our spheres, even though of course the numbers are way too low for a production case. And if you now simulate the whole thing, which I've already done, then you can see it's much easier to judge the whole thing now, because now it feels much more like sand. And also you have a much better representation of how it will look later on when we render this. So when we look at this here and render this, I mean, maybe actually let's change the background to black and then compare this with the render. You can see the two are pretty close, which makes it much easier to judge the whole thing. So this is how I would do it nowadays with the Visualize Properties node and the attribute adjust color set to random, and then you have the best solution, because also if we change anything, the simulation will not be in any way influenced by it. We can do whatever we want here and still the simulation stays intact and we don't have to re-simulate. So this makes working with grains much easier and easier to predict how it will look later when we render this. And this is why I would recommend working that way. So for now, I hope this is helpful. Thanks very much and see you later. Cheers.